All right, so before we build an organic character, you need to know a little bit more about rigging a character, which is going to be this concept of deformation. Now, we're going to get into how deformation works more precisely when we get into rigging our character, but we need to understand how our topology, which is a fancy term for the wireframe, needs to be set up for proper animation. So what I've done is I've gone and set up three finger shapes here, and if I press 3 on them, they look a little bit different from each other, but they all have the base silhouette, the base form, the base shape of each other, and they have differing topology. So let's go ahead and turn on the wireframe here so you can see it. And this is what the wireframe looks like. Now, when it comes to rigging an organic character that needs to bend, unlike our robot, which just needed to rotate, we need to use things called joints. And if I come up here to our shading here, and we turn on X-ray joints, you'll see each of these have joints inside of them. These joints are going to control vertices on the surface, generally in the form of edge loops, to make the object deform. Deform is when an object moves. Now, I've set these up to give you an example of proper deformation and improper deformation. This first one here is where we have proper deformation on our finger shape. So if I press 3, you can see it looks like a finger, but more importantly, notice that where the joint is located, we have an edge loop rolling around it. And adjacent to that edge loop, we have 2 more edge loops for it to catch on. What that does is it allows it to go from being straight like this to bent like this. And it gives you that room to deform that you need. So if I go ahead and grab one of these joints here, and I press the rotate tool to rotate this, you can see how that's going to rotate nicely. And if I come down to this one will also rotate nicely. If I press 3, you can see we get something that's bending like a finger. Now, I haven't weight painted these joints, which is the process of controlling how they bend. This is just the default weighting, and it's not great. But you can see how that looks and moves a bit like a finger, especially once we smooth it. If we come to the next one here, you'll see this one doesn't quite have the same support. It only has a singular edge running along where the joint goes. This is often enough, especially if you're doing low poly video games, if we're talking about mobile applications. This is often enough to give you what you need. You'll see it doesn't quite have the same control. It kind of just bends like so, but it works. So that is enough at a bare minimum. It's not quite as good as this. You can see how you're getting a much better detail there with that bend than you are with this one, but it can work. Now, notice this last one doesn't have any edge loops at all where the other ones do. What that means is the only things that can move are the tip and the base, making this kind of a big question mark as to what it's going to do. So let's say I wanted to bend the knuckle. Well, I can't because there is no knuckle. It just rotates between those 2 endpoints. So when you're constructing an organic character that's going to be rigged, just be aware that there is a particular way you need the topology to go. Generally, where there's a joint, you're going to want to have some sort of an edge loop to support it running across, so that way it can bend and deform properly. So in terms of the topology we're seeing here, we can go ahead and label these from worst to best. This is going to be the worst one. Basically, don't. Just don't do this. This one here is okay. This is very low end, and we're thinking something like maybe a mobile game type mesh where you don't have that much budget for geometry. And this one here is going to be sort of the best out of these. You could have a lot of variations. Obviously, you could have more geometry than this, and we'll probably see that with our toes. This is going to be kind of the bare minimum to get something good or okay. All right, so just be aware of that. Now, it's a little bit more complicated than that, though. And let's take a look at a different example. I'm going to turn off the wire on shaded here, and we're going to take a look at a pair of presumably leg things I have made. So these actually have a very basic rig, and you might notice they look the same, right? So with the finger, there's a little bit of differences because one had more geometry than the other. These have relatively the same amount of geometry. They look the same, but notice when I move the little control handle I've built for them, they're going to move differently. So let's grab that foot control, and you can see how this one bends fairly nicely, like we might expect the leg to bend, whereas this one here does not do that. It kind of crunches inward a bit, and we start to get some different shapes out of this one than we do the other one. If we turn on the wireframe, we can see why. And I'll go ahead and turn off the X-ray joints here. You'll see that this one has the consecutive edge loops running around it, and we have an edge loop we can fold over right here. So we're folding over across here. But this one over here does not. If we go ahead and take a look at this one, you'll notice that it has a quad extruded into a quad. So what we're getting is a pull here and a pull here. And we're not able to bend across this midsection. It's only able to kind of lift up and push back. And if we press 3, these also are going to smooth differently, more than likely, because they have slightly different topology. I guess they're actually pretty close. But long story short, one of these is going to move better than the other one, which is going to be this front one here, because this front one has continuous geometry. And you can see as that moves, how that bends very naturally and compresses very naturally into something that will feel like a leg. Whereas this one has that pull there, and that pull has a tendency to maintain that rigidity of the backside. And you'll see we always have that sort of calf in a way, if you will, on this leg setup, where it kind of pinches inward unnaturally. It doesn't really meld into the form like this side does. You can see how that gives in really nicely there. So if we had these running shapes, that would feel natural, whereas this one, that always has that rigid edge because it's folding differently. It's not folding across the center here. It's folding individually here and here. All right. So just be aware that when you are building a character for rigging, the topology will matter. With hard surfaces, if they're not going to bend, they're just going to rotate, they're going to twist. It really doesn't. But when it comes to characters, it does. Okay. So with that said, we'll go ahead and get rolling into modeling the character. I will guide you through the process. And following that, we'll start exploring texturing and then eventually rigging the character so we can see it all come together and you can understand these concepts better. But before you dive into character modeling, just understand you do need to have a base knowledge of the topology needed for a character to move. And it's best if you have a little bit of knowledge in rigging first, which you already do, but you haven't experienced the joint and skin system, which is what I've been demonstrating here. Okay, so let's go ahead and move forward and set up our character's modeling file.